Hello students, this video we are going to discuss about logic gates. This session is important for the CBSE, ICSE and even students who are in the engineering in the different courses, they also can get help from this. Because when we talk about logic gates, what are logic gates? जब हम लोग गेट के बारे में बात करते हैं तो गेट क्या होता है? Gate is such a thing which allows to enter things with certain restrictions. Selective entry is allowed. Similarly, when we talk about logic gates, so the logic gates are the basic building blocks of any digital system. किसी भी digital system के लिए जो logic gates होते हैं, they are the main building blocks. So logic gate we can consider as an electronic circuit which has one or more inputs, and based upon the logic selected, the particular task is performed. So that is a logic gate. So logic gate is a conditional gate, you can say, which based upon the logic gives the required output. Now there can be three categories of gates as you see: basic gates, universal gates and exclusive gates. Basic gates, universal gates और exclusive gates. अभी basic gates क्या होते हैं? When we talk about basic gates are those gates which form the fundamental unit of the digital circuit. क्योंकि बाकी जितने भी सारे gates आप देखोगे, those gates are formed using these basic gates. Now when we talk about basic gates, the basic gates are those gates as I told which form the framework of the digital circuit. और basic gates में जो सबसे पहला gate आता है, that is AND gate. What is an AND gate? AND gate is a digital circuit which gives a high output when all the inputs are high. जब सारे inputs high होते हैं उस समय AND gate high output देता है. So I hope you understand the AND gate. The AND gate gives a high output when all the inputs are high. जब सारी conditions high होंगे उस time पे AND gate high output देता है. Now when we talk about AND gate, the AND gate is, as I told, is a digital circuit which gives high output when all the inputs are high. जैसे अगर मैं AND gate के बारे में बात करता हूँ तो AND gate, as you can see, this is the symbol of AND gate. This one. This is A, this is B, and this is Y. This is represented as Y equal to A dot B. This dot represents AND. And what will happen if both the inputs, like if I am talking about a two-gate input, so two-gate AND gate, when both the inputs are high, then the output is high. For example, like your parents say, but if you get 90% and above in the examination and you are regular in your studies, means the condition is 90% and above in the examination and 90% and above in your attendance. तो अगर आपने attendance 90% पूरा किया और marks 90% आए, then your parents are going to give a reward or the school is going to give a reward. So even if you score 95% and your attendance is 50%, you are not eligible. That is AND gate. और अगर मैं कहता हूँ कि AND gate, so AND gate not only two input. If I have three gate inputs, I can have A, this is B, and this is C. What I do? A dot B dot C. So as you can see, for any logic gate we have a truth table. What is a truth table? The truth table is a representation. As you can see here, the truth table is a representation for the output for all the input states. 0 0 में क्या है? 0 0 1 it is 0 1 0 it is 0, and when both the inputs are high, then the output is high. So this is AND gate which gives a high output when all the inputs are high. You can check for a 3-input gate also. 0 0 0 output is 0, 0 0 1 output is 0, 0 1 0 output is 0, and when all the inputs are 1, output is 1. So you must be clear now that what is an AND gate? The AND gate gives a high output when all the inputs are high. Next, let us talk about OR gate. What is an OR gate? The OR gate gives a high output when either of the inputs is high. If I say, if a student gets 90% and above and he has got a gold medal in his sports, any sports activities, then he will get the admission. So even if the child is getting 75% and he has got a gold medal for his state, he will be eligible for the admission. So either of these, either he is good in sports or he is good in academics, he will be rewarded for that. So OR gate, if any of the inputs is high, now the symbol of OR gate is like this. This is A, this is B, and this is Y. For OR, we represent Y is equal to A, this is plus A plus B. So OR gate gives a high output when either of the inputs is high. अगर एक भी input high होगा तो output high होगा. That will be the requirement of the OR gate. After the OR gate, the next we have NOT gate. When we talk about the NOT gate, the NOT gate is also known as an inverter circuit, or it is also known as complement. The NOT gate is used to obtain the complement. And remember, for your MCQ, sometimes the question comes, which logic gate is there which has only one input? So this is the NOT gate. I take one input, I put a complement to it. Now this is A and this is Y. Y equal to A bar. Now if you take 0, its output will be 1, and if you take 1, its output will be 0. So the NOT gate is used to obtain the complement of a logic input. Whatever input will be provided, the NOT gate will give a complement of the input value. Next, let us talk about NAND gate and NOR gate. These are both universal gates. Now let us first talk what is the NAND gate. The NAND gate is obtained as a complement of the AND gate. अगर हम AND गेट के आउटपुट से एक NOT गेट के इनपुट को कनेक्ट करते हैं, the output which you will get, that will be the output of a NAND gate. Means I took the AND gate, AND गेट के आउटपुट को हमने एक NOT गेट के इनपुट से कनेक्ट किया. The final output which you will be getting, that will be the NAND gate. Means it is Y is equal to A dot B bar. So what will happen? As you can see in the truth table here, 0 0. The AND gate produces 0, but the NAND gate will produce its complement, that is 1. 0 1, it is 0, and the NAND gate produces 1. 1 0 is 0, but the NAND gate produces 1. 1 1. So what we will say about a NAND gate? The NAND gate gives a low value when all the inputs are high. In all other cases, it produces a high input. So we can say that Y equal to A dot bar. 0 0, it will produce 1. 0 1, it will produce 1. 1 0, it will produce 1, and 1 1, it will produce 0. So this is NAND gate. I hope NAND gate is clear to everyone. The NAND gate is used as a complement to the AND gate. Next we talk about NOR gate. What is the NOR gate? NOR gate क्या होता है? NOR gate, I will say that the NOR gate is obtained as a complement of the OR gate. The NOR gate is obtained as a complement of the OR gate. This was my OR gate. OR गेट के आउटपुट को हमने एक NOT गेट के इनपुट से कनेक्ट किया. So the final we get right. This is the NOT gate A, B, and final Y. I get Y is equal to A plus B bar. This was the OR complement. So it is A plus B bar. That is NOR gate. So we represent this as the NOR gate. Now what will happen? 0 0. OR gate used to give 0, but this will give 1. 0 1. OR gate used to give 1, but it will give 0. 1 0 0, and 1 1. This is 0. So we can say the NOR gate produces a high output when both the inputs are high. In all other cases, it produces a low output. I hope NAND and NOT is clear to you. Now the next question is that, and a very important question, why NAND and NOR gates are known as universal gates. A very important thing to recall upon, that why this NAND and NOR, they are called universal gates. Now students, you must be knowing universal. What is universal? Which can be used anywhere, which is compatible anywhere. Now we technical people have a habit of managing things. So let me just tell you a story. Once a person from England, an English speaking person, he came to Delhi, New Delhi, and he had to go to watch a cricket match which was being held at Firozshah Kokla Stadium. Now, when he reached the airport, there was a strike. So one driver came to him that, okay, today is a strike, but मैं manage कर दूँगा. Okay, ठीक है. He went to the stadium. He did not get the tickets. Again somebody came. Okay, see, you don't have the tickets, but manage कर देंगे. So and again, so there were certain times when he got this manage कर दूँगा or it will be managed. So that gentleman, when he reached his country and then he went to his president and told that, okay, the Indians have got a technology and they are able to do anything by that technology. So then the president called the prime minister that, what is this technology? And then it was like there was a tough situation between, and again they told, okay, if you don't do so, we will stop all the funds. Then the prime minister told, okay, whatever you do, we'll manage things. So this is the situation, and like we are good in managing things. Now talking about coming to the context. For example, my situation is that I need an OR gate and I do not have the OR gate. I have other gates, but I do not have the OR gate. My purpose is that I need the output of OR gate without having the OR gate. कैसे होगा ये? So that is the concept what I am trying to tell, that these NAND and NOR gates can be used to obtain any other gates. This NAND and NOR gates can be used to obtain any other gate. This is the reason NAND and NOR gates are known as universal gates. ठीक है? क्योंकि इस NAND और NOR gate से हम कोई सा भी गेट बना सकते हैं. Now let's see how it happens. This is very important, talking about your computer science as well as your physics. Plus even in many competitive exams you get this, that why they are known as universal gates, and using a particular gate, how will you obtain the other gate. Now let us talk about it and try to focus and understand it well. First let us consider NAND as AND. NAND as AND. It means I have the NAND gate and I want the output of AND gate. I have the NAND gate, but the output which I require will be of AND gate. What should be done? NAND as AND. You take a NAND gate, divide the output into two parts and pass it through another NAND gate. Right? You take one NAND gate, divide the output into two parts and pass it through another NAND gate. The final output which you will get, that will be the output of a AND gate. Just let's see. I get 0, 0. 0, 0, the NAND gate gives 1. 1, 1, it gives 0. Now if I say 0, 1, 0, 1, the NAND gate gives 1, 1, 1, it gives 0. Then 1, 0, it gives 1, 1, 1, it gives 0. Then it is 1, 1, it gives 0, and 0, 0 gives 1. So this output which I obtained was an output of AND gate. So using NAND gate, I can obtain the output of AND gate. Second, now you see NAND as OR. मतलब NAND गेट से हम OR गेट का आउटपुट कैसे लाएंगे? Now for this, I take one input A, I take one input B. I divide this into two parts and pass it through a NAND gate. I divide this into two parts and pass it through a NAND gate. I take the second input B, divide into two parts, pass it through one NAND gate. And these two outputs I combine and pass through a third NAND gate, and that is the final output of a OR gate. So to obtain OR gate output using NAND gate, what we will do, I'll take an input A, divide into two parts, pass it through a NAND gate, took the second input, passed it, divided into two parts, and again passed it through a NAND gate. Those two outputs I'll provide as input to a NAND gate. So this will be NAND as OR. Third thing, using NAND gate, if I want to obtain a NOT gate, NAND as NOT, right? NAND as NOT. Now this is input A. I want to divide into two parts. I divide it into two parts, pass it through a NAND gate. The final output which I will be getting, that will be A bar. So here I was getting A dot B. Here I was getting A plus B. And here I am getting A bar. So what you saw, using NAND gate, I got AND gate, I got OR gate, I got NOT gate. तो मेरे को NAND gate से ही सारे gates मिल गए. This is universal. Now let us see once more NOR gate. Now, how NOR can be considered as a universal gate? Now I show you NOR as OR. NOR as OR. I take one OR gate. Here, this is the NOR gate. I divide this into two parts, pass it through another NOR gate. The final output which I am getting, that is OR gate. This will be A plus B. Second, if I want NOR as AND, NOR gate की help से हमको AND gate का output चाहिए. I take this input A, divide it into two parts, pass it through a NOR gate. I took the second input, I divided it into two parts, passed it through a NOR gate, and these two outputs I passed through the third gate. This will be the output of AND gate. So this is A dot B. And third, if I want NOT gate, I took it, divide into two parts. The output which I will get, this was A, then I will get here A bar. This is A, this is B. So I hope this is clear to you that using NAND gate I obtain AND, I obtain OR, I obtain NOT. Using NOR I obtain OR, I obtain AND, I obtain NOT. So the NAND and the NOR gates, this is the reason they are known as universal gate. I hope it is clear to everyone. You can just take a screenshot of this and you can save it for your reference. Now, one more thing important is that we already discussed that we can obtain any gate using the NAND gate. Now the question comes, if I want to make a digital circuit, again slowly I will come back to the XOR and XNOR. Before that, again I want to complete the application of this logic circuits. For example, if I say that I have to make a logic circuit for a Boolean expression. I have two inputs A and B, and I have to draw a logic circuit for example, I have A and B, and I want AB plus A bar B. F is equal to AB plus A bar B. Now I have two inputs A and B. I am taking this A, this is B. AB means I have to use AND gate. This is the AND gate. AB. Now A bar B, I take this A only here and I add a complement to it. This is A bar and I take this B. I draw the logic circuit for A bar B. Now this plus, what does it denote? It denotes that there has to be a OR gate. Now I'll take this two inputs, this is A bar B, I'll pass it through a OR gate and I get this final output. This is F. This is clear, I hope, that we can make the logic circuit. Now the question was that this logic circuit has to be made using only NAND gates. Right? I have to use only NAND gate and make this logic circuit. F is equal to AB plus A bar B. This has to be made using only NAND gate. Now, let's say I have this input A, I have this input B. First I need AB. What I'll do? I took this input and I made a AND gate. This is AB. Then A bar. Now what is to be done here? Okay, I had NAND gate I have to use, so I took this and again I divided into two parts and again I passed through one NAND gate. So this gives me finally AB. Right? This is AB I got. Now the second part, A bar B. For that, first I need to have this A bar. A bar how I'll get? I divide into two parts. I pass it to a NAND gate. This will give me A bar and this is the B. I pass it to a NAND gate. Again the output is divided into two parts and again passed through a NAND gate. So this gives me A bar B. Now I have to get this plus. For the plus, what I have to do again? For this, I will take this, divide into two parts, pass it through a NAND gate. Again I divide into two parts, pass it through a NAND gate and take these two, pass it through a third NAND gate. This will give me the final outcome. So what you saw, I needed an AND gate, I needed an OR gate, I needed the NOT gate. I did not have anything. Using only NAND gate, I was able to draw the logic circuit for AB plus A bar B. Does it make sense? Yes. So that is what is the concept of the universal gates, that using these gates, you can obtain the output of any other gate. So remember students, these logic gates, they are very important, and the universal gates again, they help you to understand the logic for any gate. You can make the logic using the logic circuit of these particular two gates, universal gates, NAND and NOR. Now comes the third category of logic gates, that is exclusive gates. What is exclusive? What do we mean by exclusive? Exclusive means that is exclusively be made. Now this exclusive gates, they are made by combining the AND, OR and NOT gates. Combining these three gates, we can get the output of the exclusive gates. Now what is exclusive about them? The exclusive gate, the first one, that is XOR gate. The XOR gate gives a high output when odd number of inputs are high. The XOR gate gives a high output when odd number of inputs are high. So A XOR B, as you can see here, the logic circuit of A XOR B, and internally it is AB bar plus A bar B. So what does it mean? When it is 0 0, it will give 0. When it is 0 1, it will give 1. When it is 1 0, it will give 1. And when it is 1 1, it will give 0. The internal structure of an XOR gate is A bar B plus AB bar. The same applies when we have a 3 input gate. Again, when there are 0 inputs high or 2 inputs high, then the output will be 1. Otherwise, the output will be 0. So the condition for XOR gate is that the XOR gate gives a high output when odd number of inputs are high. Next, let us talk about XNOR gate. What is an XNOR gate? You can just see here once again the output of the XOR gate, the truth table. 0 0 it is 0, 0 1 it is 1, 1 0 it is 1, and 1 1 it is 0. The next we talk about XNOR gate. The XNOR gate is obtained by combining again the AND, OR and the NOT gate. This gate gives a high output when even number of inputs are high. When even number of inputs are high, then the XNOR gate gives a high output. In the XNOR gate, what happens that 0 0 it will give 1, 0 1 it will give 0, 1 0 it will give 0, and 1 1 again it will give 1. The XNOR gate internally it is A bar B bar plus AB. A bar B bar plus AB means when both the inputs are 1 and both the inputs are 0, it gives a high output. In other cases, it gives a low input. So this session, as I told, this is basically for understanding the concept of logic gates. What are logic gates and how do we use it? In the next session, we will be discussing the application of logic gates, and then again we will be discussing on certain other factors. Next one we will be discussing this encoder, decoder, multiplexer, that we will be discussing, and again we will discuss other applications of the logic gates, and then K-map in the coming videos we will be discussing. Students, try to understand that these logic gates, they are the building blocks of your electronic circuit. Whether you are going for your class 12th examination, or you are going for your engineering classes, or you are going for your competitive examinations, this is going to help you. So, all the best to all of you, and keep following for further videos on this topic. All the best to all of you.